Good morning and welcome back to the podcast. It's Saturday, June 21st, 2026, and we've got a packed show ahead. Today we're covering 8 major stories, and they paint a surprisingly coherent picture about where AI is actually headed. First up, robotics. China's unveiling a humanoid called MOYA that's disturbingly lifelike. We're talking 92% human-like gait, while Boston Dynamics is doing something maybe even more impressive, teaching their Atlas robot new skills in under an hour through simulation. Then we shift gears. Europe's in a panic. There's this viral Doomsday scenario floating around Brussels called Europe 2031 that's actually influencing policy, and we're going to dig into whether it's prescient or just hype. We've also got 3 stories directly about controlling and operating AI agents at scale. Home Assistant getting AI integration, a company called Nace AI solving the autonomy supervision problem with something called Hypernetworks, and a framework for actually owning your agents in production so they don't drift into disaster. And if that wasn't enough, we're talking about how SaaS businesses survive when AI commoditizes everything, how the real AGI shape is emerging. Hint, it's not one super intelligent model, it's coordinated systems. And Unreal Engine 5.8, letting developers use Claude to build game worlds. A lot to unpack.
That's a lot. And honestly, what strikes me about all 8 of these stories is that they're answering a different question than we were asking a year ago. A year ago, it was all, what can AI do? Can it write? Can it code? Can it see? Today's question is completely different. It's, how do we actually own this thing? How do we control it? How do we keep it from drifting? How do we make sure it stays useful and doesn't become a black box? That thread runs through everything we're covering today, from agent ownership frameworks to Europe's anxiety about not controlling its own infrastructure, to how you embed AI into your SaaS business model in a way that competitors can't just strip out. So yeah, 8 stories, but really one conversation.
That's a sharp read. And it actually changes how we look at some of the hardware stuff too. When people see MOYA or Atlas doing impressive things, they get excited about the capabilities. But underneath that is the question: who owns the infrastructure that makes these robots work? Who controls the data pipeline? Who maintains the agents? That's the real story in a lot of these. So let's dig into the robotics piece first and see what China's actually pulling off that the US isn't, and then we'll move into the ownership and control angle. All right, so let's break down what actually happened in the robotics space this week. And this is where it gets interesting. We're talking about 4 separate announcements, all within days of each other, all pointing in the same direction. First, China's Droid Up unveiled this humanoid called MOYA, 5.5 feet tall, 70 pounds, and here's the unsettling part. It has warm silicone skin, like body temperature, and a gait that registers at 92% human-like accuracy. They're pricing it at $173,000 for elder care and hospitality applications. That's the flashy one everyone's talking about. But I think the more impressive engineering story is actually Boston Dynamics Atlas.
Yeah, I saw those Boston Dynamics clips. What's the actual breakthrough there versus what everyone's hyping?
The simulation to reality transfer speed. Atlas can now simulate millions of training hours in a single day. Millions. In one day. And then transfer learned skills to the physical robot in under 1 hour. So they trained it to move objects in the 50 to 70 pound range, and it immediately moved a 100 pound plus refrigerator without retraining. The engineering advantage is elegant. They redesigned Atlas with only 2 actuator types instead of many, and symmetric limb design with no cross-joint cables. That simplicity means the simulation matches physical reality almost perfectly, so the transfer works.
Okay, so that's the speed multiplier. They removed the engineering complexity that usually breaks simulation to reality transfer. But that raises a question. If Atlas is this good at learning and adapting, why haven't we seen it doing complex work in the wild yet?
That's fair. Right now, it's still very much in the research to application phase. But the third story gives you a peek at where this heads. Agibot, a Chinese company, just had their Yuanjiang A3 complete the first fully autonomous table tennis match. Full-size bipedal humanoid playing table tennis autonomously. And they did it with a 20 kHz spike camera. That's 10 times faster visual response than conventional cameras. So we're not just getting humanoids that look human, we're getting sensory systems that react faster than humans can process.
Right. And then you've got Alibaba, layering the software stack on top with Quen Robot. Is that the ecosystem play?
Exactly. Quen is 3 integrated models: Nav for movement navigation, Manup for manipulation tasks, and World for environmental prediction. They trained Manup on 38,000 plus hours of data, and it topped the Robo Challenge benchmark at a 45% task success rate. So while Boston Dynamics is proving you can transfer skills quickly, Alibaba is building the unified software brain that could coordinate a whole fleet of Chinese hardware. This is infrastructure play, not just hardware flex.
And that's where the strategic divide becomes really obvious, right? Because here's what's interesting. The US is still dominating on the AI and software side. OpenAI, NVIDIA, the reasoning models. But when we look at actual embodied hardware that's moving and doing things, China is winning on hardware production scale and integration. Unitree, Agibot, UB, Xpeng, these companies are moving at speed. Why is that split happening?
A few things converge. First, China has massive manufacturing ecosystems already built for electronics and robotics components. Second, there's less regulatory friction around robotics deployment there. And third, I think there's a strategic focus difference. The US invests heavily in the reasoning layer because the assumption was, get the AI good enough, and the hardware will follow. But what we're seeing is that embodied AI isn't just drop a GPT into a robot. You need hardware that's designed from the ground up for how the models will actually operate. And China's been iterating on that faster because they're not treating hardware and software as separate problems.
So the question for the next 18 months isn't really who has the smartest model. It's who can actually deploy intelligence into systems that move and change the world. And that seems to favor the countries that have both the hardware supply chain and the willingness to ship at volume.
Exactly. And once you have that, once you have Quen Robot or something like it as the unified software layer, and you have dozens of hardware partners building robots on top of it, then you have an ecosystem. You're not competing robot to robot, you're competing system to system. And the US still doesn't have that stacked up yet.
Which brings us back to the ownership question we started with. Because if you're a company or a country, what you actually care about isn't the flashiest robot demo. You care about whether you control the stack from bottom to top. And right now, China's demonstrating they can do that faster than anyone else. The US has pieces, but not the integration. That's the real story here.
And that integration speed matters, because we're not talking about incremental improvements anymore. We're talking about the first generation of humanoids that can actually be deployed commercially. MOYA at $173,000. Atlas learning new tasks in 1 hour. Autonomous table tennis as a proof of dexterity. Once those hit manufacturing scale, the applications expand exponentially. The team that owns the full stack owns the next decade of robotics, and right now, it looks like that might be China's.
Okay, so we've got to talk about this thing that's been making the rounds in Brussels and policy circles everywhere, called Europe 2031. It's a thought experiment, basically speculative fiction, that imagines the European Union economically devastated because it failed to invest in AI infrastructure while the United States and China raced ahead. The scenario went viral, got read by members of the European Parliament, showed up in UK-German policy discussions, and here's the uncanny part. It was published literally 1 day before Trump's administration actually blocked foreign nationals from accessing Anthropic's Fable model, so it read like it was prescient.
So it's fiction that became self-fulfilling prophecy by sheer timing. But let me dig into what the scenario actually rests on, because I've been looking at the citations. The authors point to these massive United States megadeals as proof that the US is committed to building the infrastructure Europe isn't. They cite OpenAI and NVIDIA partnering for $100 billion, OpenAI and Oracle for $300 billion. Those are supposed to be the real evidence that America is serious and Europe is asleep. Except, most of those deals have actually collapsed or are underwater. What does the scenario do with that contradiction?
The authors acknowledge it, actually. They say they're aware of the AI bubble concerns and they know individual projects fail. But their argument is that the general trajectory is still valid, that the commitment to build the infrastructure exists on the US side, even if specific megadeals are shaky. The core claim is still, Europe regulated, Europe hesitated, Europe didn't build the data centers, and that will leave it economically irrelevant in an AI-dominated world.
Okay, but that's building a sweeping policy argument on a foundation that's demonstrably cracking. If the $100 billion and $300 billion deals are already collapsing, then what does the scenario actually prove about real US commitment? And here's what actually concerns me. This is part of an emerging genre. We've seen AI 2027 Fred by J.D. Vance. We've seen other doomsday scenarios move markets. How much of actual policy is now being shaped by speculative fiction instead of by evidence of what's actually working?
That's the real question, isn't it? Because the scenario taps into something that's genuinely true. Europe is more cautious on AI regulation, investment is fragmented, there's no unified data center build-out like you see in China or even in parts of the United States. So people read the scenario and they think, oh my God, we're going to fall behind, and suddenly it's policy making on fear rather than strategy. But the scenario also proposes a solution, massive data center investment, and the authors even admit people hate data centers, there's mounting resistance to it. So you're building a whole policy panic on a scenario that acknowledges its own solution is unpopular.
So we've got a fictional story built on shaky infrastructure megadeals, proposing a solution that's politically radioactive, and it's getting cited in real policy discussions because it feels urgent and it fits the narrative that everybody's already scared of. That's not analysis, that's narrative-driven policymaking. And the question it raises is, what does Europe actually need to do to not fall behind? Is it really just build more data centers like the US is? Or is there a smarter play that doesn't require betting the whole continent on contested infrastructure projects?
And that circles back to the theme we started with. It's not about who has the smartest model or the biggest infrastructure anymore. It's about who owns and controls the whole stack. Europe's fragmentation is real, but copying the US data center strategy might not be the answer if the US strategy itself is shaky. The more interesting question is, where can Europe actually differentiate? What can they build that China and the US can't easily replicate? That's the conversation that should be happening in Brussels, not panic about following the same path.
So now let's shift to something that's more directly relevant to people who are actually running their own tech stacks at home. There's an unofficial Home Assistant integration that just dropped. It's called the HA-MCP repository, and it's basically a model context protocol server that lets AI agents like Claude talk directly to Home Assistant. No custom scripting, no YAML files, just natural language. You can ask Claude to control devices, read sensor data, and create automations through conversation.
Wait, so instead of I have to write automation rules in YAML or I have to tell Google Home to turn off the lights, you're just talking to Claude about what you want your home to do.
Exactly. The MCP server acts as a bridge between the LLM, Claude, Hermes, whatever you're running, and Home Assistant's actual API. So Claude can read what your sensors are showing, understand the state of your devices, and execute commands or create automations, all through conversation. It's community-driven right now, so it's not officially supported by Home Assistant, but it's built on the MCP protocol, which is the same pattern we've been seeing pop up everywhere, in Unreal Engine, in other integrations.
This is huge for power users, though. because Home Assistant's whole appeal is that you own your data and your automations. You're not locked into Google's ecosystem or Amazon's. But the barrier to entry has always been you have to be technical enough to write YAML configs. So what happens when you remove that barrier and let anyone just talk to the system?
You unlock a whole category of users who want control but don't want to become automation engineers. And practically speaking, the MCP approach means you likely need either a local LLM setup, like running Llama or Hermes locally, or API access to Claude or another cloud-based agent. But either way, you're bypassing the traditional smart home assistant model. You're not talking to Alexa or Google Home. You're talking directly to your own infrastructure through an AI interface.
So the real shift here is the interface. Instead of tell Alexa to dim the lights, you're asking Claude, I'm about to have a video call, can you set the room to meeting mode? And Claude understands that means dim lights, close the blinds, set temperature to 70 degrees, maybe unmute the speakers. It's conversational context instead of explicit commands.
Right. And because it's tied to your Home Assistant instance, all the data stays local, the automations live on your hardware, and you're not training anyone's model on your home patterns. The MCP integration fits the same architecture pattern we're seeing elsewhere. Agents as a coordination layer on top of infrastructure you own. Home Assistant was already powerful if you knew how to write YAML. Now the question is, does adding a conversational AI layer actually make it more powerful, or does it just make it more accessible? And honestly, for most people, accessibility wins.
So we've been talking about owning AI agents and keeping them in line. But here's the problem that's been blocking teams from actually scaling agents. The two approaches everyone's been using, fine-tuning and retrieval augmented generation, or RAG, they both break at scale. Fine-tuning bakes knowledge into the model weights, but update the knowledge and you get catastrophic forgetting. You have to retrain the whole thing. With RAG, you throw more and more context at the model, and the retrieval accuracy just degrades. All 18 models tested showed degradation as context grew. And here's the kicker. Retrieval misses look exactly the same as confident wrong answers. The system sounds just as sure when it's lying.
So you're saying the current approaches to keeping agents updated and accurate both hit walls. That's the core problem, is how do you keep an agent current without either rebuilding it constantly or overwhelming it with retrieval noise? So what's NACE AI's answer here? Hypernetworks?
Exactly. Instead of fine-tuning your model or stuffing context into it, Hypernetworks generates small, task-specific models on demand at inference time. Think of it like this. You have a policy that says, here's what this agent should know about compliance. Here's the current rule set. Here's what just changed. The Hypernetwork doesn't update the base model. It generates a lightweight adapter, basically a small model, that knows how to apply those policies right now, in this moment. They call it text to LoRa as the proof of concept. And those generated specialist models are 10 to 30 times cheaper to run than using a frontier model for the same task.
Okay, so you're moving from update the model to generate a specialist model for this specific task right now. But that sounds like you're just shifting the supervision problem, not solving it. You used to have to supervise fine-tuning. Now you have to supervise the policy that generates the specialist model. And if the policy gets stale, the generated model is just going to be confidently wrong in a different way. How does that actually reduce the supervision burden?
That's the right skepticism, and honestly, it doesn't eliminate supervision. What it does is compress the supervision window. Instead of having to retrain or fine-tune, which can take days or weeks, you're regenerating a specialist model from a live policy at the moment you run the agent. So the information is fresher. And because the specialist model is narrow, it's not trying to be good at everything, the failure surface is much smaller. Fewer things can go wrong, which means fewer things escalate to needing human review. NACE AI's commercial product, MetaModel, is actually designed for regulated workflows, compliance work, audit trails, things where you need to prove the agent read the right sources and applied the right rules, and they're reporting 90-10 human-in-loop ratios as an outcome, not a goal, an actual measured outcome.
Wait, 90% autonomy, with only 10% needing human review? That's a massive jump from where most agent implementations are landing. But I want to dig into the failure modes, because you're generating these specialist models on the fly from policies. What happens when the policy itself is wrong or outdated? You've just moved the drift from the model weights to the policy layer. How do teams actually catch that?
That's where the ownership framework from earlier becomes critical. Every agent needs to know where it's reading from, its diet. If you're generating a specialist model from a compliance policy, you own knowing that policy was updated yesterday, not 6 months ago. You own the review loop. You run the agent, check the output, mark assumptions or sources that look stale, and you improve the policy. The Hypernetwork approach actually makes that easier because you're not debugging a massive fine-tuned model. You're checking, did this policy actually encode what we think it does? Did the specialist model apply it correctly? That's a much tighter feedback loop than traditional fine-tuning or RAG.
So the claim is that by making the specialist models narrower, more current, and cheaper, you're actually able to supervise them more carefully because there's less surface area to monitor. And NACE AI raised $21.5 million in seed funding on this. That's real capital commitment. But here's my last question. This works great for regulated, compliance-heavy work where you can control inputs and policies. What about the messy, open-ended agent work? Research synthesis, creative work, things where the policy isn't clear. Does the Hypernetwork approach break there?
Honestly, yeah. The approach is strongest when you have a clear policy, clear rules, clear sources, clear outcomes. Where it struggles is exactly where you said. Unstructured work, where the right answer depends on judgment or taste or context that doesn't fit neatly into a policy. But here's the pragmatic take. Most business agent work is actually messier than you'd think it looks on the surface. Product story refinement, compliance reviews, customer support triage, they all have hidden policies. The teams that win in 2026 are the ones who make those policies explicit, document them, and then use tools like Hypernetworks to enforce them at scale. The teams that lose are the ones pretending the work is pure magic that can't be systematized. And NACE AI's bet is that most enterprise AI work actually falls into that first category.
So we've covered all the exciting breakthroughs: robotics, reasoning, agents. But here's the uncomfortable question underneath all of it. What does this mean for every SaaS company that's been selling software features for the last decade? Because here's the reality. If your product is a UI plus some logic, an AI agent can replicate that. It just learned your feature set, and boom, you're commoditized. So the question becomes, how do you build a SaaS business that doesn't get flattened by agents? And the answer is, you stop selling software and start selling something agents can't easily copy. That means data network effects, vertical specialization, deep workflow integration, and shifting entirely from selling licenses to selling outcomes.
Right, so the move from here's a tool to here's how this tool integrates into your entire process and captures value only you can capture. But I want to dig into what actually separates a defensible vertical SaaS from one that just gets replaced, because specialization sounds like a strategy, but Anthropic can specialize an agent too. They can fine-tune or customize their reasoning for whatever vertical you're in. So, what's the actual moat? Why is becoming embedded infrastructure harder to displace than building a specialized feature?
The key is data network effects and operational embedding. Let me be concrete. A SaaS tool that just says, "We'll summarize your sales calls better," is pure feature replacement. An agent can absolutely do that. But a sales tool that's been running inside your organization for 3 years, capturing every call transcript, every deal outcome, every win and loss pattern, that tool has learned your sales process. the data becomes a moat. If you leave, you're leaving behind 3 years of institutional knowledge. Compounding on that, if the tool is woven into your daily workflow, your reps use it to log every interaction, your managers use it to review deals, your executives use it to forecast, switching costs become enormous. You're not replacing software, you're rewiring an organizational muscle.
Okay, so it's not the feature. It's the switching cost created by integration depth and accumulated data. But here's the hard question. Doesn't that advantage evaporate if an AI agent can just absorb all that data and workflow knowledge in a conversation? Here's 3 years of our sales data. Here's how we work. Now optimize for us. Why can't Claude or a specialized agent do exactly that?
Because agents are stateless. They don't retain institutional memory the way a system embedded in your workflows does. You run an agent, it processes, it outputs, and next time you ask it something, it starts from scratch unless you feed it the same context again. That's not integration. That's consultancy. A defensible SaaS becomes infrastructure because it's always running, always updating, always learning your specific patterns. It's not ask the agent when you need help. It's the system is monitoring your sales cycle, flagging risks in real time, adjusting forecasts as data comes in. That continuity, that operational presence, is what agents can't easily replicate. And the third piece is guarantees. Agents are probabilistic. A SaaS business selling into regulated or high-stakes verticals can actually guarantee outcomes. If you use our system, your compliance audit will pass. If it doesn't, here's what we owe you. Agents can't make that promise. The liability is too high.
So you're saying the actual defensibility is a combination: deep workflow integration that creates switching costs, continuous operational presence that agents can't replicate statelessly, accumulated proprietary data that gives you an information advantage, and in regulated verticals, the ability to take liability and guarantee outcomes. That's a high bar. Most SaaS companies aren't building any one of those, let alone all four. So what does that mean for teams trying to position themselves right now in 2026? If you're a SaaS founder and you're not embedded that deeply, are you just doomed?
Not doomed, but you need to hedge. And this is where Chris's portfolio approach actually makes a lot of sense. You don't bet everything on one vertical SaaS. You launch small, you learn which niches have real stickiness, and you double down on the ones where workflow integration is actually possible. You're looking for verticals where the data accumulates, where regulatory pressure is high enough that outcomes matter, and where your customers would actually face real costs if they switched. Trading tools, compliance software, field service optimization, those are easier to embed than consumer social features. And if you're building horizontally, if you're trying to serve everyone, you need to accept that you're commoditized. So you shift models. You're not selling software licenses. You're selling outcomes. You're selling, we improved your conversion rate by 20%, or we cut your operational costs by 30%. You're selling the result, not the feature. That way, even if an agent can replicate what you do, you're not competing on the feature. You're competing on whether the client got the outcome they paid for.
Which is a fundamentally different business model. You're not done when you ship the software. You're done when the client hits their outcome target. That's higher risk because you're responsible for adoption, for integration, for making sure it actually works in their environment. But it's also higher defensibility because the switching cost is results, not habit. And I think that's actually the real SaaS apocalypse story. Not that agents will wipe out SaaS entirely, but that SaaS businesses that are purely feature plays are going to get hammered. And the ones that survive are the ones that become operational partners, not product vendors. They stop selling software and start selling business results. That changes everything about how you think about retention, pricing, and what you're actually optimizing for. Okay, so we've been talking about better models, smarter reasoning, all these individual capability improvements. But here's what's actually interesting about what Fusion Agents and Abacus AI are doing. They're not competing on model quality. They're competing on system architecture. And I think that's the real shape of AGI emerging right now. It's not one superintelligent model, it's coordinated systems that reason, plan, and actually deliver results.
Okay, unpack that for me. Because when you say coordinated systems instead of one smart model, that's a pretty different mental model of what AGI even means. Walk through how Fusion Agents actually works, because I think that's the concrete example of what you're describing.
So Fusion Agent solves a problem you hit when you're running production AI. Frontier models are expensive and slow. Claude or GPT-4 is amazing at reasoning, but you can't run it on every task. You run out of budget and latency explodes. Fusion's answer is, use an expensive planning model, a good reasoner, to decompose complex work into parallel subtasks, then distribute that work to cheap, fast worker models. The planner says, here's the strategy, the workers execute in parallel, and then you synthesize the results back together. So on a bug fix, the planner might say, analyze the error, search the codebase, generate a fix, write a test. 4 parallel worker tasks. Each one is cheap, each one is fast. Then you orchestrate the outputs back into a coherent fix.
So you're trading reasoning depth on individual tasks for breadth and speed through parallelization. And the cost comes down because you're only running the expensive model once for planning, and then cheap models handle the grunt work. But here's the question. If the worker models are cheap and fast, aren't they also less reliable? How much quality do you lose by distributing work to commodity models?
That's the architecture insight, though. The expensive model does the hard work, figuring out what needs to happen and in what order. That's the reasoning bottleneck. The cheap models just execute specific, well-defined tasks. Search the codebase for patterns matching X. Generate a function signature from this spec. Those are narrow problems. Cheap models are actually pretty good at narrow, well-defined work. They just struggle with the planning part. So you're distributing to where the work is actually easy, not skimping on the hard part. And they're showing this works across PR reviews, resume screening, equity research, bug fixing, things that look complex but are really just plan this elaborate task, then execute steps in parallel. The efficiency gains are enormous.
Interesting. So the competitive advantage isn't we have a better model, it's we architected the system so that expensive reasoning is used only where it matters. That changes how you think about scaling AI. But then there's Abacus AI, which seems to be doing something different. They're generating interactive outputs and actual infrastructure. What are they actually pulling off there?
Abacus is the flip side. While Fusion is about orchestrating multiple models efficiently, Abacus is about making AI outputs actually useful in workflows. Instead of generating text, Abacus generates interactive artifacts. You ask it to analyze a dataset, and it spits out a lucid chart diagram, a 3D visualization, a Tableau dashboard, something you can actually use and interact with, not just read. But here's the part that matters operationally. Abacus can also deploy real infrastructure. You ask it to set up a machine learning pipeline, and it provisions servers, configures models, creates public endpoints. It's not a mock-up, it's actual deployable stuff.
Wait, so the AI is generating both the design and the infrastructure to run it? That sounds like it could go catastrophically wrong. If the AI misconfigures something, you've got a live service potentially broken. How much supervision are we talking about here? And what's the fallback if the generated infrastructure is fundamentally misguided?
There's definitely oversight required, but the point is, the bottleneck shifts. Instead of a human architect designing the infrastructure, writing deployment scripts, configuring servers, and then a human engineer reviewing it all, you get a first draft infrastructure from Abacus that a human reviews. It's not unattended, it's supervised, but it collapses a huge amount of boilerplate and design work into a prompt. And the examples they're showing are genuinely impressive. Equity research dashboards that pull from financial APIs, app review analysis systems that ingest data, create summaries, and surface anomalies. These aren't toy examples, They're real workflows that took months to build before, and now take days.
Okay, so Fusion Agents is about orchestrating models for efficiency, and Abacus is about generating complete systems, outputs plus infrastructure from prompts. But what connects them as the real shape of AGI? Because those sound like two different problems.
They're solving the same underlying problem from different angles. The old assumption was build a smarter model, and it will handle everything. But what's actually working is build systems that know how to reason, plan, coordinate, and deploy. Fusion reasons about task decomposition, Abacus reasons about system design. Neither of them is betting that a single model, no matter how powerful, will just magic away complexity. Instead, they're building the infrastructure so that AI can reason about infrastructure. They're systems that think about systems, better language model or faster reasoning. That's approaching AGI as a working system, not as a single superintelligent model.
So the claim is that AGI doesn't emerge from one model getting so good it can do everything. It emerges from systems that can reason, plan, coordinate work across models, and actually deploy infrastructure. And the competitive advantage isn't better weights, it's better architecture. That actually reframes how we should be thinking about the AI race, because it's not just who trained the biggest model, it's who can orchestrate models effectively. Is that actually what we're seeing play out right now, or is this aspirational?
It's playing out right now. Fusion and Abacus are shipping. Teams are using them. And here's the pragmatic signal. The companies winning in this space aren't trying to build the next OpenAI. They're not trying to train foundation models. They're building orchestration layers and system generation tools on top of existing models. That's where the actual product market fit is. And it makes sense, because foundation models are becoming commoditized. If you can use Claude or open source models and build smarter systems on top of them, you've got more product flexibility, lower infrastructure costs, and faster iteration than if you're trying to train your own models. So the winners are the people who crack the system architecture problem, not the model training problem.
Which circles back to the ownership and control theme we started the show with. Because if AGI is coordinated systems rather than one model, then what you actually need to own is the orchestration layer, the reasoning about how to decompose work, how to deploy infrastructure, how to supervise the output. That's a different skill than train a big model. It's more like systems engineering meets strategy, and the teams that excel at that are going to define what AGI actually looks like in practice, not the labs building bigger transformers. So Epic Games just announced the Unreal MCP plugin for Unreal Engine 5.8, and it's a fairly straightforward idea with potentially massive implications. Basically, LLMs like Claude can now directly interact with the engine through text prompts. You describe what you want, a cityscape with specific lighting, a hazard-filled scene, asset placement, and the AI manipulates the engine to build it. Epic's claiming that work that would take months can now take days.
Okay, but months to days is a pretty aggressive claim. I've heard that kind of timeline compression before. Are we talking about genuine acceleration of actual game development pipelines, or is Epic showing us best-case scenarios where everything happens to work perfectly on the first try? Because in real development, you don't just prompt once and ship. You iterate. You fight with the engine. You discover the AI didn't understand what you actually wanted. How much of that friction are they accounting for?
That's fair skepticism. And to Epic's credit, their VP actually pushed back against the AI replaces game engines narrative. The framing is explicitly AI-assisted game creation, not AI builds games. The demos show the developer retaining override control. The AI handles broad iterations, but humans make the final decisions. So it's not prompt once and walk away. It's more like AI generates a first pass, you refine it. AI generates variations, you pick the best and tweak. But you're right to question the timeline math. A project that would take months might be genuinely compressed to weeks instead of days, but Epic's marketing language is definitely optimized for headlines.
Right. So the real productivity gain is probably faster iteration cycles rather than complete projects in a fraction of the time. But here's what interests me more. What does this do to the actual skill set game developers need? Because if you're not writing C++ or working in Blueprint visually anymore, if you're describing what you want in natural language and letting Claude handle the implementation, that's a fundamentally different job. Are game developers excited about this? Or are they worried they're about to become prompt engineers?
That's the real culture shift, I think. And it probably depends on the developer. Experienced level designers and technical artists who've spent years learning Unreal systems might see this as, finally, I can stop wrestling with engine minutiae and focus on creative intent. But you're describing an entire skill rewrite for a generation of developers. The thing that made you hireable 3 years ago, deep knowledge of the engine, becomes less critical. What matters is understanding design intent, being able to communicate it clearly, and having the taste to supervise what the AI generates. That's a different skill set entirely.
Which circles back to something we've been saying all day. The winners aren't the ones with the deepest technical knowledge anymore. They're the ones who can integrate AI into their workflow and maintain quality control. For game developers, that means thinking like a creative director who's collaborating with an AI that understands the engine deeply. But here's the practical question. Is the MCP pattern mature enough that a studio can actually ship games with this right now? Or is it still researchy enough that the real adoption is a year or two out?
The plugin is available immediately to Unreal developers, so technically it's shippable now. But the honest answer is that the demo context might not reflect real-world production complexity. A single AI generating a cityscape in controlled conditions is different from coordinating AI assists across environmental design, character animation, gameplay systems, and performance optimization across platforms. That's where the actual game development bottleneck sits. So I'd say the near-term reality is probably indie studios and rapid prototyping seeing the biggest gains. AAA pipelines are more complex, and integrating AI there successfully requires rethinking how whole departments collaborate. That takes time.
So what you're saying is, yes, this is genuinely useful, and yes, it will accelerate iteration. But the months to days narrative is marketing, and the real story is more interesting. It's about how this forces game development studios to rethink their entire pipeline and skill requirements. The MCP pattern is working, the tech is real, but adoption and execution are where most studios are going to struggle. That's actually more interesting than the headline claim anyway. Okay, so we've covered robotics, we've talked about system architecture, we've looked at all the exciting breakthroughs, but here's what nobody's talking about. How to actually keep an AI agent from becoming a black box that drifts into disaster. And the problem is real. Teams spin up agents for research, for code review, for automating some workflow, and then 6 months later, nobody knows what it's reading, nobody knows if the inputs are still valid, and the agent's confidently outputting nonsense because nobody owns it. So let me give you a framework that changes this. Every agent that actually matters, every agent that reads files and produces work people depend on, needs 4 things: a job, a diet, boundaries, and a review loop.
Wait, so you're saying the technical problem isn't actually building the agent? It's the operational problem of keeping it honest. Why is that distinction important? Aren't agents supposed to just work once you build them?
That's exactly the trap. People assume agents are like software. Build it, ship it, it's done. But agents aren't software. An agent is a system that reads context, produces work, and affects other people's workflows. Without clear ownership, it drifts. It uses stale data. It repeats the same bad patterns because nobody's checking. And here's the scary part. Wrong answers from an agent look exactly the same as right answers. It's confident either way, so the team using it has no signal that something's gone wrong until someone actually looks at the output and says, "Wait, this is garbage." By then, How much bad work has it been producing?
Okay, so the framework is designed to prevent that drift. Walk me through the four pillars. What does each one actually do?
First, the job. Every agent needs a one-sentence purpose, not vague, not help with product work. Something like, read the PRD, support tickets, and design docs, synthesize them into a refinement packet. That's specific. That's ownable. Second, the diet. What does this agent actually read? Is it pulling from live customer feedback or from a stale spreadsheet from 3 months ago? Who updates that data? How often? If you don't know the diet, you don't know how current the agent's knowledge actually is. Third, boundaries. Read-only access to data. Or does the agent write things? Does it create automations? Does it send messages? Without clear boundaries, an agent that should just read something might start modifying your infrastructure. Fourth, the review loop. You run the agent, check the output, mark assumptions or sources that look wrong, improve the inputs or the prompts, and run it again. That's continuous.
That sounds like a lot of overhead for every agent. Is this really the expectation that teams are going to establish ownership and maintenance cadences for multiple agents, or is this more for mission-critical agents that actually affect the business?
Good question. And the honest answer is, if you're not willing to own it, you shouldn't spin it up. But here's the thing. Ownership doesn't mean full-time babysitting. It means clarity. You need to document one thing for each agent: the owner, the job, the diet, the boundaries, and the review cadence. One person's name on that card. And you need to know the known failure modes. When does this agent get it wrong? What inputs cause it to hallucinate? If you can't articulate those, you don't understand the agent well enough to run it in production. But once you do that groundwork, the maintenance becomes routine. You're not debugging agents constantly. You're checking them on a known schedule, seeing if the inputs are still fresh, and updating the policy if they're not.
Let me make this concrete. Give me a real example. A product team that's actually trying to scale this. What would their agent roster look like?
Perfect example. Product story prep agent. The owner is the product manager. The job is read the current PRD, read recent support tickets, scan the design mockups, check the sprint backlog, synthesize all of it into a refined story packet ready for the team. The diet is PRD updated by PM, support tickets from last 30 days pulled from the help desk, design files from Figma, backlog from Jira. Boundaries, read only. The agent reads, it doesn't modify anything. Review loop. Every sprint, the PM checks the output packet, marks assumptions, notes which sources looked stale, and feeds that back. If support tickets suddenly change category, the PM knows to tell the agent, hey, we reorganized support, here's the new structure. That's ownership in action. Without it, the agent would keep reading from a category structure that doesn't exist anymore, and the output would be garbage.
Okay, I see how that works for a single focused agent. But what happens when someone like Chris, who's launching multiple small AI-assisted businesses, has 5 or 10 agents running across different projects? Trading bots, dev tools, automation for different domains. How does ownership scale across a portfolio when you're already stretched thin as a solo builder?
That's the real challenge you're asking about. And the answer is, you can't scale agent ownership the way you scale code. Code scales through abstraction and libraries. Agents don't. Each agent has its own job, its own diet, its own specific workflows. But there are systems-level things you can do. First, you create an agent roster, literally a document or spreadsheet that lists every agent you're running: name, owner, job, diet, boundaries, review cadence, known failure modes. That roster becomes your source of truth. Second, you batch the reviews. Instead of checking every agent constantly, you review all of them on a fixed schedule, end of week, end of sprint, whatever your cycle is. Third, and this is important, you're ruthless about decommissioning agents that nobody wants to own. If you've got an agent running and you can't assign an owner who'll actually check it, kill it. It's doing more harm than good. because it's quietly drifting and degrading the quality of work people depend on.
So there's a discipline to it. You're not running as many agents as you possibly can. You're running as many agents as you can actually own and maintain. That's a different optimization. Most teams try to maximize agent deployment and minimize oversight. You're saying flip that. Minimize agents, maximize ownership.
Exactly. And here's the distinction that matters. Prompting is asking. You ask an agent something one time, it answers, you use the answer, you're done. That's fine. But agent work is delegating with context and care. You're saying, read these sources, produce this work, and I'm going to check it and improve the policy that governs you. That's fundamentally different from a one-off query. And if you're not willing to do that, if you're just launching agents and hoping they work, you're going to build a system full of confident hallucinations, dressed up as clean output.
So the skill that actually wins in 2026 isn't can you build an agent, it's can you own an agent and keep it current. And that's going to require a discipline that most organizations haven't figured out yet. Because the temptation is always going to be to launch more agents, integrate them more deeply, automate more workflows. But you're saying the real competitive advantage is actually the opposite. Tight ownership, clear boundaries, continuous review. That's less glamorous, but it's what actually delivers value.
That's exactly it. Building agents doesn't earn you anything in 2026. Owning agents that deliver value does. And the only way to deliver value is to know exactly what you're running, where it's getting its knowledge, what it's allowed to do, and whether its outputs are actually helping or hurting. That discipline separates the teams that scale AI assistants successfully from the teams that end up with a portfolio of broken, drifting automations that nobody trusts. The winners will be the ones with an agent roster and the discipline to maintain it.
So let me step back and try to connect all 8 of these stories, because individually they're impressive, but together they paint a picture of how fast the ground is shifting under everyone's feet. Hardware advancement is outpacing what software people expected. We're talking humanoids that look human, robots that learn in an hour, embodied AI actually doing real work. Meanwhile, the software side, the reasoning models, the AI agents, everyone's still arguing about whether they work. But here's what's actually happening. The hardware is forcing the software to catch up, not the other way around. China gets this, the US is split, and Europe is basically panicking.
Right. And that panic, the Europe 2031 scenario, that's a symptom of something deeper. Europe's not actually falling behind because it didn't build data centers. It's falling behind because it's not building systems. It's not integrating hardware and software and policy and execution into a coherent stack the way China is doing with Qwen and Alibaba and Agibot. And the US is building pieces, best reasoning models, best AI software layers, but those pieces aren't integrated yet. The US has depth in AI, China has breadth in integration, and Europe has neither at scale. So the panic is rational, but the response, just build more data centers, is missing the actual problem.
Which brings us to the core insight we've been building toward all episode. Agents are becoming real operational systems, not toys. This isn't ask Claude a question and get an answer. This is deploy an agent that reads data, produces work, affects workflows, and gets better over time. And the teams winning right now aren't the ones building smarter models. They're building smarter systems around models. Fusion agents orchestrating cheap workers with expensive reasoning. Abacus generating deployable infrastructure. Home assistant agents handling smart home automation. These are systems, not features.
And that's where the real business consequence hits. Because if your entire company is built on the assumption that you're going to sell software, features, UIs, licenses, and those features are becoming commoditizable by agents, then you're in trouble. But if you can embed yourself operationally, if you can become infrastructure that's hard to rip out, if you can accumulate data and switching costs and regulatory compliance, then you survive. That's the SaaS apocalypse story. The companies that don't adapt their business model from selling software to selling outcomes and operational integration, those are the losers. And the companies that do? They're going to thrive because they're competing on something agents can't easily replicate.
Which means the other big loser category is anyone running agents without owning them. Because we talked extensively about this. You spin up an agent, it drifts, the inputs get stale, and before you know it, you've got confident hallucinations affecting real workflows. The skill that wins in 2026 isn't can you build an agent fast, it's can you operationally own agents and keep them current. That requires discipline that most organizations don't have. It means documenting the job, the diet, the boundaries, and the review loop. It means assigning an actual person to be responsible. And it means being ruthless about decommissioning agents nobody's willing to own.
So here's what we're looking at as we head into the rest of 2026. The winners are building systems, not models. They're operationally embedding AI into their workflows, not launching flashy demos. They're treating agents as infrastructure that needs maintenance, not as magic solutions. And they're adapting their business models to compete on outcomes and switching costs instead of feature parity. The losers are the ones who assume AI is just the next software wave, that you can commoditize it and move on, and the ones running agents without clear ownership, clear boundaries, and clear review loops. For everyone listening who's trying to position their business or their team in this landscape, that's the dividing line. Can you own it operationally, or are you just hoping?